Hello, welcome to CM Square, and in today's chemistry lesson, I'm going to do one questions for topic 5, energetic SL part. And this paper 2 question is from May 18 times 22 question 4. It's very recent past paper, so please do you know how to do it in your exam? And in this topic, I would say there are two key formulas you should know to calculate the enthalpy change of a reactions. So delta H equals the enthalpy change of formation of product minus reactant. So first one, product minus reactant. And the second one is that using a bond enthalpy to calculate the enthalpy change of reactions is bond broken minus bond formed. So it's very common to see in exam, the question asks you to calculate the delta H for a reaction, either using the bond broken minus bond formed, that means using the bond enthalpy values, or using the enthalpy change of formation values of the compound. So you have to use product minus reactant. So please remember these two formulas. For these questions, enthalpy changes depends on the number and the types of bonds broken and formed. Hydrogen gas can be formed industrially by the reaction of neutral gas with steam. So methane CH4 with steam to form a hydrogen gas and carbon monoxide. So find the enthalpy change of reactions in kilojoules using section 11 of data book. So section 11 of data book is a bond enthalpy values. So that means now we have to use this formula. Delta H equals bond broken minus bond formed. And bond broken is for reactant and bond formed is for product. Right? So the first step, we have to draw the Lewis structure of all these compounds so that we know what kind of bond and what bond we are going to break. So CH4 is 4 single bond, 4 CH single bond. Water is OH single bond. And hydrogen gas single bond. But CO is a triple bond. And bond broken minus bond formed. So bond broken is for reactant, we have to break 4 CH bond. And the value for CH bond is 414. And also we have to break 2 OH bond, OH single bond. So OH single bond is O to H here, 463 times 2. And for product, we have to break 3 HH single bond. So HH single bond is here, 446. And also 1 CO triple bond. So for multiple bond, you can find it here, but CO triple bond is not given on the data book. That's why it's given on the question here. CO triple bond is 1077. So now we can use the calculator. And the answer is 197 kilojoules positive. And part B, the table lists the standard enthalpy of formation of some of the species in the reaction above. So only the hydrogen gas is not given. Why? So part 1, outline why low value is listed for H2. And you can't even find it from data book because the value for the enthalpy change of formation value for an element is 0. That's why it's not given. So because H2 is an element. And that's the answer. So assume that the question assume you know that the element with 0 value for the enthalpy change of formations. And part 2, find the value of delta H in kilojoules for the reaction using the values in the table. So the values in the table are the enthalpy change of formation values. So now we have to use the formula delta H equals enthalpy change of formation product minus reactant. So product 3 times H2 0. And also 1 mole of carbon monoxide. negative 111, and minus the reactant. Reactant is CH4 and H2O. Negative 74.0 plus negative 242. Is positive 205 kilojoules. And last questions. Outline why the value of enthalpy of reaction calculated from boiling enthalpy is less accurate. So actually, for the same reaction, using enthalpy change of formation and using the boiling enthalpy, you will get a different value, but just slightly different. And which one is more accurate? Always the formation value is more accurate and the boiling enthalpy is less accurate because, so let's look at the data book here. Average boiling enthalpy. And the answer is that because boiling enthalpy is averaged value. That's why it's not that accurate.